Find the weight of the sphere in the open air in pounds force. In this problem, a sphere with a diameter of 1.5 feet is submerged in water, which has a water temperature of 60 degrees Fahrenheit. The weight of the sphere when measured on a balance underwater equals 85 pounds force. The question asks to find the weight of the sphere if weighed on a balance in the open air. The difference between the scale reading when the sphere is submerged and when the sphere is in open air equals the buoyant force Fb, which acts in the upward direction on the submerged sphere. The other forces acting on the submerged sphere include the upward force exerted on the sphere by the scale, which we know equals 85 pounds. The last force in the vertical force equilibrium is a downward force, which is the weight of the sphere in air, which is what we're trying to solve for. Summing the forces in the vertical direction, we can isolate the weight of the sphere in air, which equals the buoyant force plus the weight of the sphere in water. We know the weight of the sphere in water equals 85 pounds force. So we're left to solve for the buoyant force Fb, which equals the unit weight of water times the volume of the sphere. The unit weight of water equals the density of water times the gravitational acceleration times a unit conversion. The density of water slightly depends on the temperature of the water. At 60 degrees Fahrenheit, the water density equals 62.37 pounds mass per cubic foot. The acceleration constant equals 32.17 feet per second squared. And the unit conversion, GC, equals 1 over 32.17 pounds force seconds squared per pounds mass foot. Therefore, the unit weight of water computes to 62.37 pounds force per cubic foot. The volume of the sphere, V sphere, equals 4/3 times pi times the radius of the sphere cubed. The problem provides the sphere diameter as 1.5 feet, which means the sphere radius equals half that value, 0.75 feet. And the volume of the sphere computes to 1.767 cubic feet. Now we can solve for the buoyant force, Fb, which equals 110.21 pounds force. And when added to the weight of the sphere underwater, the weight of the sphere in air equals 195.21 pounds force. When reviewing the possible solutions, the answer is D.